Okay, so we just went over exponential rules. So I'm just going to remind you, when you have two things connected with multiplying, we added. When we had an exponent to an exponent, we multiplied. When we had division, we subtracted. Okay, so remember that. Multiplying, add, exponents, then you times, division, you subtract. Okay, that correlates to the log rules. So do you see how in here I have the log of something multiplied? So if those are multiplied, look what I did. I separated them with adding. Does that kind of mean here was multiply, so we added the exponent? Quotient rule. If I have two things here divided, I separate them into two different logs with subtraction. Easy to remember because I knew these were divided, I subtracted. And then here the power rule. So if I have something to an exponent, then I can change it to a multiply. So again, kind of correlates to this. If you have something to an exponent, you multiply. Okay, here we go. We are going to separate this, and when we separate it, it's going to become three different things. So there's going to be 1, 2, and 3. Okay, you ready? They all have a log A. So the first thing is going to be 3 log AX. So why did I do that? Because the rule says exponents can become multipliers. So instead of exponent 3, I multiplied by 3. Then the y is a multiplier. So how do I separate multipliers? I add. And then the last item is on a divider. So how do I detach dividers? I subtract. Okay, so you split multipliers with adding. You split dividers with subtracting. And if there's an exponent, you can move it to a multiply instead. Multiply by 3 instead of exponent 3. Multiply by 2 instead of exponent 2. Okay, kind of see it? Okay, this next one, there's a couple things I'm going to do here. I'm going to change the square root of x to read x to a half. And when I think about this, there's going to be 4 items. Because I'm multiplying, dividing, multiplying, like this is its own, this is its own, this is its own, this is its own. Okay, so you're going to separate. Ready? The first item would be a half log 5x. Because I moved the exponent on the x to now say a multiply by. The y is a multiplier, so I'm going to do a add. The 4 is a divider, so I'm going to subtract. And the z term is a divider, so it's also going to be subtracted. Okay, it's on the bottom, so it's a subtract. Okay, some people get confused because they're like, well, that is times by that, which you could do minus that product but then it would create a minus and a minus. Okay, how many items do I have here? So this is treated as one item. You can't separate x and 2 because they are added together. Do we have a rule about separating adders? No. So that's its own thing. The 4 is its own thing. And then that is its own thing. So there's going to be 3 separations. So log 7 bracket x plus 2. Because it's a clump together. Okay, the 4 item is on the bottom, so I'm going to minus. And then the y item is on the bottom, so I'm going to minus. Okay, so this is the foundation to everything from the whole rest of the unit. If you can't understand these rules, you're not going to be able to do 50% of the questions on the test. These rules are going to be the foundation for everything. Got to have them mastered. Okay, now we're going to try putting this together. So this is a log 7 of a bunch of stuff. Can you glue it back together? I've had one that got separated, so now you can glue it together. So what I'm going to do is this multiplier, I'm going to undo it and put it back to an exponent. So m squared. Okay, so I can see that I'm going to move all of those like that. So m squared, there's going to be a y to the 4th, there's going to be an x cubed. And now I just look if they're adders or subtractors. So this n is an adder, so it's going to be a timeser. Then this was a subtractor, so it's going to be a divider. This was a subtractor, so it's going to be a divider. Okay, so here are some trickier questions. I want you to look at this and I want you to identify right now what kind of expression is this. Is this an exponential or a logarithmic expression? It is an exponential. So this is the base. This is the exponent, and it will equal some kind of result. So it is an exponential. So can you change to a log? Can you change this to a log? So here I go. Log of, and I write the base, write the result, write the equals exponent. Okay, do you see what I did there? I literally just maneuvered all those parts that I labeled. Base, exponent, result. Okay, can you make a math conclusion? Log 8 something equals log 870. So what do you know about this? It has to be 70. Okay, so this is the exact same thing. So that's the base. This is the exponent. Base exponent equals result. So I want you to change it to a log. So log of, put the base, put the results, equals exponent. Okay, we can't conclude what we did before because this is log 4 something, this is 3 log 4 something. So I need them to start the same. We just learned a rule. If you have a multiplier like this, what else could you do with it? You could move a multiplier to be the exponent. So now, both sides of my equation look the exact same. Log 4 something equals log 4, 5 cubed. So therefore, what can you conclude about my question mark here? It would have to be the same as that. So my answer is 125. Okay, we are going to do the rules in a little bit of a different way. So using the rules, we can only multiply, divide, have an exponent, and FYI, exponents also include radicals, right? Okay, I need you to figure out, how can you make a 20 using 4, a 5, and an 8? You need some kind of combo, 4, 5, or 8, and you can only multiply, divide, or use exponents. Anybody know how to get to 20 using 4, 5, and 8? You can multiply something, divide something, exponent something. I'm not trying to be tricky. This one's pretty straightforward. 4 times 5. Is that legit? 4 times 5 is the same as 20, right? Okay, if 2 items are multiplied, what could you do? What's the rule? You can separate them with adding. Okay, if you want to just leave your calculator alone, I can try to do this faster, just the number at the end. So I just added those numbers. Okay, how do I get to a 16? Using a 4, a 5, or an 8, I'm allowed to multiply things, divide things, or exponent things. Do you have a way to get to 16? 4 squared? 4 squared. 4 squared is the same as 16. I'm allowed to use exponents. Okay, what's the exponent rule? Exponents become multipliers Okay, anybody, I need you to get a 1.6 using a 4, a 5, and 8. I can times things, divide things, exponent things, radical things. Anybody got something for me? What's that? What did you say? 5 divided by 8? Close.
8 divided by 5.
8 divided by 5 is 1.6, yes. Okay, now, how do I rule this? If there's 2 dividers, what could I do? I can separate them with subtraction. Okay, last one is the tricky one. I need to get to a 10. How can I get to a 10? And you have one of these on the test, a little bit trickier like this. You have to get to a 10. You can use a 4, a 5, and 8. You can use anything that's multiplying, dividing, or exponents, radicals.
5 times 8 divided by 4.
Yes, but I don't want to do that one. I want to do something harder. That does work, but I wanted you to see something that's a little bit harder.
5 times 4.
Does that work? Does that get me to 10? Square root of 4 is 2. 2 times 5 is 10. Okay, why can I use the square root of 4? Because it's the same as an exponent. So how would you separate my equation? How would you separate my equation here? You would do a half log A4, move exponent to multiply. Okay, a couple more and then we're done. Evaluate these. So here's what your brain is doing. The base was 4, the result was 64. I'm trying to figure out the exponent. So kind of I maneuver it like this to think 4 to the something is 64. And anybody want to guess what that'd be? 4 to the, that's multiplying. Don't do that. That's a big number. 4 times 4 times 4 to the power of 4. It's 4 cubed. 4 cubed. So that's a 3. Okay, so then the next part was log 4, 2. So if the base was 4 and the result was 2, what is the exponent that makes that happen? One half. Does anybody know the mental math? What happens when you divide by a half? It's a multiply by 2, so my final answer is 6. Okay, this one you have to start with log 216. So here's what my brain is doing. If the base was 2 and the result was 16, I have to think about the exponent. My brain has to do the exponent part, which is 2 times 2 times 2 times 2, right? So now I have a new question. The base was 16 and the result was 4. So again, this is what my brain is doing. That's what I'm visualizing every time. 16 to the what? Square root of 16. Okay, square root is the same as a half, right? Okay, so on the next one, we're going to do that. But I don't do multipliers. So what do we do with the multiplier? Oh. That's your alarm. Wake up. So I moved it there. And then that's 64. So we actually, I think, just did this one because my brain would go, the base of 4 to some exponent gets me to 64. So that would be 3. So there's my new expression, log 9, 3. So here's my brain. The base is 9. I'm trying to get exponents, and I need to get to 3. So this is what your brain is doing. 9 to the what? Half. Square root. Okay, last question. This one on the test, not a lot of people got it. It's pretty straightforward though. 3 things are separated. So what are you going to do? We're going to glue them back together. So log 6 of, glue it. So the 36, instead of add 24, how do you glue adders together? times, how do you glue back together a subtractor? Divide. Da 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 da, in my calculator, 216. So I'm trying to get the exponent. Remember, the answer is the exponent. So your brain goes like this. Base 6 to what is 216? Anybody want to guess? 2 to the 4? Too big. 3. Obviously 2 squared is 36. 36 times another 6